Hello my dear students, welcome back to Aditya Tutorials. I am Rahul, and in this video I am going to discuss the modern periodic law and modern periodic table. So whatever you're looking on your screen, this is the modern periodic table. Okay, and the some features are there with this modern periodic table that we're going to discuss right now here. This is modern periodic table. Modern periodic table. And you should know that in the previous section I was explained you that how the modern periodic table is constructed. This construction is based on increasing order of the atomic numbers of elements. We have arranged the various elements in order to get this periodic table as increasing order of their atomic numbers. You can see here atomic number of helium is 1, where the atomic number of here the atomic number of hydrogen is 1 and atomic number of helium is 2. The lithium is 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9 and neon 10, like that. In the increasing order of their atomic number it is arranged and we get this periodic table. Okay, and some features are there. I just want to explain about this. If I write the number of columns here, just I want to mention here the number of columns here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and total there is 18 number of columns are present. I just write here 18 columns. 18 columns are present. Okay, 18 columns. And if I want to check that how many number of horizontal rows are there, this is the first row. This is first, second, third, fourth, fifth, and this one is sixth, and this one is seventh. I'm not going to write here 8 and 9 because this is the extra part of the periodic table that should be inserted here in between the 3 and 4. In between this should be whatever the pink color is there. Now here I have to place this. Okay, so it means that there are total 7 periods are there. These are the horizontal rows are there. Now these are called as periods. Okay, and one thing I want to mention right here, that periods are nothing but represented as n, and n we know that this is principal quantum number. This is principal quantum number, and the principal quantum number indicate that this shell number in the atom, right? This is the first shell, second, third, fourth, fifth, sixth, seventh shell. Okay, and now one more important point I want to tell you here, that is here in the 18 columns are there, and these 18 columns are called as groups. They are called as groups, and in the groups, the electronic configuration, that is I'm going to write here, electronic configuration is same. Okay, so it means that the first group is there, its electronic configuration is constant here. Along all the elements belongs to this group have the same electronic configuration and same chemical properties too. Okay, if I take here 18th group, that all are the noble gases. They are less reactive because they contain 8 electrons, and hence they are less reactive because of containing 8 electrons in the outermost shell. Okay, now what I will do that I will get to know about the electronic configuration in the periods. We know that in the groups electronic configuration is same, but what about the electronic configuration in the periods? Okay, and therefore what I do, I just write the heading here, that is the first one, the first period. This is the first one, first period, and you just notice here in the first period what is there. We have in the first period we have hydrogen, then here we have helium, only 2 elements, right? So it contains it is actually the very short period. It is generally called as it's not called as short period, it is called as very short period. It is called as very short period, and it contains only 2 elements, contain only 2 elements here, and the configuration for the first period it should be 1s. There should be 1s, the configuration, because in the 1s there should be accommodation of 2 electrons, therefore 2 elements are there. Okay, now so in this period correspond to the principal quantum number, where here I written here n is equal to 1 means the principal quantum number is equal to 1, and because of this reason it is called as a first period. Okay, it accommodates maximum of 2 electrons here, and therefore this implies only 2 elements. 2 elements here. Okay, and move to the next one, that is second. Second is that is second period. Second period. In the second period, the electronic configuration should be 2s and 2p. This second period, right? So therefore here this is you can notice in the periodic table how many elements are there: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. There are total the 8 number of electrons are there, right? And therefore it is called as short period. So short period, and it contains total 8 elements. And that is from the lithium to that is lithium to neon. There are total 8 elements are present, and the principal quantum number for this can be given as n is equal to 2. Principal quantum number is equal to n is equal to 2 here, and therefore we written here 2s 2p. Okay, where the p orbital again divides into 2px, 2py, and 2pz orbitals that can accommodate a maximum of 8 electrons. Okay, when n is equal to 2, the maximum electrons should be here 8 electrons. Okay, and then after move to the next one, that is third period. Okay, so thing is that in the third period, the electronic configuration to be here 3s and 3p. This should be 3p it is. And in this you can notice how many elements are there. So here starting with the sodium, because the third period is there, 1 2 3 4 5 6 7 8 elements are there. Again here the 8 elements are there like in the second period, and therefore I'm going to write here that is it is short period. And it contains 8 elements here also. And one more point is that the elements start from the sodium and end up to argon. There are total number of elements are 8 elements are there, and the principal quantum number you can notice that 3s and 3p is there, and therefore n is equal to 3 here. And in this case the orbital fill up the 8 electrons, therefore we have here 8 elements. So here in the 3s 2 and 3p 6, total 8 electrons are there, and therefore this implies here 8 elements. Hope you understood this part. Next move to the another point, that is here, that is fourth one, that is fourth period. A fourth period is very important because the electronic configuration we write here 4s, 3d, and 4p. And total number of electrons we can write here 2 plus 10 plus 6, that is 18 electrons we're going to write. So therefore in the fourth period, this is generally called as, you can notice here how many elements are there in the periodic table. This start with the potassium 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 elements are there. There are 18 elements. Okay, so contain 18 elements, and hence it is called as a long period. This is called as long period because it contains more number of elements, that is 18 elements in that. And one important point I want to mention here, that is in the fourth period the elements start with the potassium and end with the krypton, and it corresponds to the principal quantum number, that is n is equal to 4, because the 4s is the principal quantum number here is 4, and therefore is the 4. And the other numbers we have here, and 4s, 3d, and 4p orbitals are filled in these orbitals, that is 4s, 3d, and 4p orbitals filled in this orbitals. Okay, next the fifth one, that is fifth period. In the fifth period we have the configuration 5s, then 4d, and 5p. Just look at the elements. So here also in the fifth orbit, fifth shell, this is in the fifth period, we have again 18 number of elements. Again I'm going to write here, it contains 18 elements. 18 elements are present here, and along with that this is called as a long form period. Okay, And the principal quantum number is here, that is 5, because you are written here the 5s. And now the elements starting from in the fifth period are from the, that is rubidium. You can notice here rubidium is there here, Rb, rubidium, rubidium 2, and next it ends with a xenon, rubidium 2, xenon. That is elements from the Rb to rubidium 2, xenon, Xe. So there are total 80 number of elements are there, therefore it is called as long period, and principal quantum number is 5 over here. And the elements in which in these elements the electrons fill up in the 5s, 4d, and that is 5p orbitals. Next go for the sixth period. Sixth period. This is quite important, student, for your examination also. So this is the concern part here, and here the orbitals are 6s, 4f, 5d, and 6p. Okay, so these are the orbitals which belongs to the sixth period. In the sixth period start from the that is cesium, and ends with a radon. You can notice here, that is sixth period, cesium, Cs, and ends to the radon, Rn. Okay, I'm going to write, and it contains total of 32 elements here. 32 elements. How 32 elements I will explain here. 32 elements, and you can notice here that 32 elements, 6, this is cesium 1, 2, 3, and come here 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, like that. So their total number of elements here are, you have to continue up to radon. You will find that there are total number of elements are 32. Okay, so hence this is very long period. This is very long period. Very long period it is, and this period correspond to the principal quantum number here, n is equal to 6, because here is a 6s is there, therefore it is n equal to 6. It starts with the filling of 6 s or electrons, because it contains 2 plus 14 plus 10 plus 6 orbitals, and up to the 6p orbitals. The total, there is 16 orbitals are there here. If you sum up these all, you will get here 16 orbitals, and you know that each orbital contains here, can accommodate a maximum of 2 electrons. Therefore 16 into 2 equals to 32 electrons, and this implies that this period contains 32 elements. Okay, now move to the next one, that is seventh. So in this you can notice that in the periodic table the total number of elements are started from francium to the lawrencium, but in between this there is incomplete. It is actually because it is the last period where it is incomplete. The seventh period start from the francium. Better I will write the electronic configuration. It start with the 7s, 5f, and the 6d. So this should be incomplete, because in future we can get more number of elements with a different electron configuration, therefore it is incomplete. And it start with the francium, that is francium, alkali metals, francium. You can notice here this is started with the francium. Here is a francium here. So francium to the next, but I will write here francium to it is started from francium. It is an incomplete period. Francium to whatever next, it is incomplete period. Incomplete period. You note this word is important, incomplete period. Similar to filling up the 4f orbitals, the 14 electrons belongs to the and 5 of orbitals are also placed separately bottom of that periodic table here, and these are called as actinides. A previous one where I forgot to explain you that these are called as lanthanides. But this is the sixth period. This is actinides, belongs to that is seventh period. Now they are called as actinides, that is separately kept in the bottom of the periodic table. The various periods and the corresponding orbitals being filled are shown in another table I'm going to show here. That just check it. The total sum of the things what we have studied here. So periods I'm going to write here. Periods, and length. What is the length, or you can say the number of elements in that, and the number of elements, and orbitals filled. Just you have to check out this and complete this, because see what we have to write in this case. We have 1, 2, 3, 4, 5, 6 and 7. There are 7 periods are there. In the first it is very short. This is very short. Second period is short, and third is also short, and the fourth is long, and fifth is also long, and sixth is very long, and the seventh one is incomplete. It is incomplete. And number of electrons I'm going to write here. In the very short, there's the first period, only 2 elements are there, and here there are 8 in the second. Third contain 8. Fourth contain here 18 elements. Fifth also contain 18 elements, but 6 contain 32 elements. And right now, seventh is incomplete, but even though it contains 28 elements. Okay, so now let's understand that how the orbitals are filled. In the first period, there is only 1s atomic orbital is filled. In the second period, there is 2s and 2p is filled. And in the third orbital, the 3s and 3p is filled. And in the fourth orbital, that is important, 4s, 3d and 4p orbitals are filled. Next, at the fifth period, we have 5s, 4d and 5p orbitals are being filled. And in the sixth, this is quite important, this is 6s, 4f, 5d and 6p orbitals are being filled here. Now last one is 7s, 5f, 6d and 7p orbitals are filled. So this is a very in short it is we just explained here. Okay, in the next video I'm going to discuss here the classification of periodic table into the blocks.